Hello children, once again I welcome all the standard 10 students for the video learning subject chemistry lesson 1 chemical reactions and equation. Dear student, I know because of lockdown you may not have proper study materials with you like copy book etc. For book, I uploaded PDF of lesson 1 that is chemical reaction and equation in Campus Care. You can utilize this for your study. Regarding copy, you can use the leftover pages of previous year notebook. Thank you. Let me start today's teaching that is characteristics of chemical reactions and equations. These are the following characteristics of chemical reactions. Number 1, change in color, change in state, change in temperature, formation of precipitate and evolution of gas. I will teach one by one all these properties with examples. Number 1, change in color. Some chemical reactions are characterized by a change in color. For example, if you take potassium permanganate, I suppose all of you know very well the original color of potassium permanganate solution is violet in color. When you add lemon juice drop by drop to this violet color potassium permanganate solution, the color of potassium permanganate start fading and finally you will get a colorless solution. So that is the purple color of potassium permanganate becomes colorless. Second, copper sulfate. The original color of copper sulfate is blue in color. When you add iron nail, which is black in color, or you can say dark grey in color, it will lead to the formation of ferrous sulfate and copper. Here, you can see the change of color from blue to green. The ferrous sulfate solution is green in color. Change of color from blue to green. At the same time, you can observe the formation of copper, which comes in the form of brown precipitate. Next example, as already has seen all around you during rainy season, especially the iron materials just like kava, tawa, kadai, etc. turns to with a coating of a reddish brown coating. This reddish brown coating is nothing but it is known as rust. How it happens? Iron when exposed to oxygen in presence of water, it will form hydrated ferric oxide. This hydrated ferric oxide is known as rust and the color of this is brown in color, reddish brown in color. Iron again you can see here dark grey or black changes to brown color and all the three are the type of chemical reaction or chemical changes where you can find the change in color. Now next property that is change in physical state. Physical state refer to the condition at which any chemical substance can exist or present in the room temperature. If you take a wax at room temperature, children, what is the physical state of wax? That is in solid state. Wax at room temperature is solid state. When we burn the wax, on burning, it turns to carbon dioxide and water. Carbon dioxide, it is in gaseous form, water is in liquid state. So you can see the change in physical state from solid wax to gaseous carbon dioxide and water. So we can say very well some chemical reaction are characterized by a change in state. Likewise, next example, magnesium. When you take magnesium ribbon, which is again in solid state, on burning in presence of oxygen, magnesium will form magnesium oxide, which is white ash. The magnesium oxide thus comes in the form of white ash. Next chemical property, that is change in temperature. In most of the chemical reaction, the temperature changes. Temperature changes means either heat will be absorbed or heat will be released during the chemical reaction. When the heat is evolved during the chemical reaction, then the process is known as exothermic process, or the reaction is known as exothermic reaction. So we can say the chemical reaction in which heat energy is produced during the chemical change, it is called exothermic reaction. For example, calcium oxide. The common name of calcium oxide is known as quicklime. Calcium oxide commonly known as quicklime. When quicklime is added to water, or we can call this one as in Hindi as chuna. When we add water in quicklime, it will form calcium hydroxide along with the evolution of heat. So as the heat is evolved during the reaction, we can call this one as an exothermic reaction. Likewise, when you burn coke or coal, etc., any combustible substance, when you burn, they burn in presence of oxygen to form carbon dioxide. Along with the carbon dioxide, it evolved a tremendous amount of heat, either huge amount or less amount, but heat will be always produced. So we can call this one as a exothermic reaction. In other words, we can see all combustion reaction. That means combustible substances, when they burn, they produce heat, and hence we call that one as a exothermic reaction. Children, for your knowledge, we can say respiration. Respiration is also considered as an exothermic reaction because during that process heat energy is produced. Next is endothermic reaction. The chemical change in which heat energy is absorbed during the reaction and the temperature of the reaction mixture falls is called endothermic reaction. For example, barium hydroxide solution, when added with aluminum chloride solution, it will form barium chloride, ammonia gas and water. And during this process, the heat get absorbed by the solution, and hence we can call this one as an endothermic process. Next type of chemical reaction, that is lead with the formation of precipitate. In standard 9 already you had done in practical reaction between sodium sulfate and barium chloride. Let us discuss once again here. Precipitate is an insoluble substance formed as a product of a chemical reaction which separates out of the solution, and hence this reaction we can call as a precipitation reaction as well, or we can see as a characteristics of a chemical reaction where precipitate form. For example, when you take potassium iodide solution aqueous for a chemical reaction, to make it more understanding, you can write here aqueous, solid, liquid, whatever be the physical state of the chemical reactant and product. So potassium iodide, the original color of potassium iodide is colorless. It is colorless. Added with lead nitrate solution, it is also colorless. So both the chemical substances are colorless. When we mix these two solution, we will get the yellow precipitate, yellow PPT or precipitate of lead iodide and potassium nitrate form. This potassium nitrate remain in aqueous solution. So here you can find two type of characteristics. One is change in color, that means colorless solution to yellow precipitate. At the same time, we can keep this one under the characteristics of formation of precipitate. Likewise, when you take sodium sulfate aqueous solution mixed with barium chloride, which is also In aqueous solution, both the solutions are colorless. On mixing the two solutions, you will get barium sulfate, which will comes in the form of white precipitate, and it will form sodium chloride, remain in the aqueous solution. So some chemical reactions are linked with the formation of precipitate. Now, next, chemical properties, evolution of gas. In some chemical reaction, a gas may evolve. For example, when you heat calcium carbonate, it is in the solid state. On heating strongly, it will turn to calcium oxide along with the liberation of carbon dioxide gas. So, chemical reaction may cause the evolution of gas. Likewise, if you add zinc granules in dilute solution of sulfuric acid, it will form zinc sulfate and liberate hydrogen gas. Next example, hydrochloric acid with sodium carbonate. If you add solid sodium carbonate in dilute solution of hydrochloric acid, it will form sodium chloride, liberate carbon dioxide gas. Children, for showing the gaseous state, you can put the arrow mark upward direction. For precipitate, you can show it pointing downward direction, or you can write G for gaseous state. So here hydrochloric acid reacts with calcium sodium carbonate to form sodium chloride, carbon dioxide gas, and form water. So these are the examples to show that chemical reaction may leads with the formation of or evolution of any type of. Now my next topic is chemical equations. What is a chemical equation? Chemical equation is a statement that describes a chemical reaction in terms of symbols and formula. That means for writing all these chemical reactions, we can represent in simple way by writing their formulae and symbols. For example, when nitrogen reacts with hydrogen, nitrogen reacts with hydrogen to form ammonia. The symbol or chemical formula for nitrogen is N2 and that of hydrogen is H2. For you children, be careful writing the chemical formula. Don't write the symbol, directly symbol of an atom. Here you have to write the molecular formulae of reactant and product. Nitrogen, N2 only, not N. Don't write N for nitrogen symbol. If you write N, that stands for an atom of nitrogen. Likewise, hydrogen, here hydrogen in the form of gaseous state, nitrogen as well in the gaseous state. So we represent the gaseous state of the element in the molecular formula, and molecular formula of nitrogen N2, hydrogen H2, and the ammonia form, that is NH3. All the three, nitrogen, hydrogen and the ammonia form, are in the gaseous state. So we can say chemical reaction when we represent through a formula of the reactant and product becomes a chemical equation. One more example, if you take aluminium reacts with chlorine to form aluminium chloride. Aluminium reacts with chlorine to form aluminium chloride. What symbol or formula can you write for aluminium? That is Al. Al is the molecular formula and symbol of aluminium both, because aluminium is a monoatomic element. Whereas chlorine, for the writing the formula for chlorine Cl, if you write, it will be wrong, because chlorine is a gaseous element, and in the gaseous state the molecular formula is Cl2, because gaseous state the elements are diatomic in nature, and the aluminum chloride thus formed becomes AlCl3. Here, for writing the molecular formula, we use the valencies of aluminium and chlorine. Aluminium valency is 3, chlorine valency is 1, and hence the formula is AlCl3. That's all, children, for today's teaching. I hope all of you understood very well. If not, you can put your doubts in the assignment column. I can clear your doubts, and please do practice of writing the chemical equations. Whatever the chemical reactions in the all the 5 properties I given you, try to write the equations for all those examples. That is your home assignments. I hope all of you will do. We will meet in next video. Thank you.